Hello. So today I would like to run an experiment, which I've already done actually. So this is slightly cheating. I'll explain what happened. But um, my experiment is to see to what extent current tooling can automate proofs of simple statements. And so what I'm going to use is a proof that was just supplied by Bruno Le Floch for the Equational Theories Project a few days ago, yesterday in fact. So in this project, which is now basically completed, we've been proving implications between magma laws. And there was an implication which was rather tricky. It was first proven in the 90s with a computer-assisted proof, but now we have some human-readable proofs. So there's an equation which we call E1689, and it's an equation concerning magmas. A magma is a set of a binary operation, like multiplication, but not necessarily associative, or in fact, obeying any law. And equation 1689 is the claim that x is always equal to y times x times z times z for any x, y, and z in the magma. And it turns out that this law implies the singleton law, that it implies that x equals y for every x and y. That's E2. But all the proofs are somewhat complicated. Bruno has kindly supplied a human readable proof in about a page. And so it's just a whole bunch of symbol manipulation. It doesn't require any fancy external libraries. So this should be straightforward to formalize. So I tried to formalize this in Lean using the latest AI tools. So let me switch now to my IDE. So this is my third attempt to do this. The first time I did this, I didn't read the proof. I just went into a code, and about 5 lines in, I got stuck. I didn't understand a step in the proof. So the recording just shows me sort of staring at this umming and ahhing for a few minutes. And then I abandoned that attempt. The second attempt, I actually went all the way through the proof and I finished it. But unfortunately, the screen share did not work properly. So the recording was not really usable. It took 48 minutes to complete the whole thing. So now it's my third attempt. So I've actually formalized this once already. So I kind of know what to do. So this is not a perfect demonstration. And it is possible that the AI tools are now contaminated. They may know the proof already. I've erased it, but they may still keep it in memory. So this is not a fully sort of scientifically controlled experiment. But anyway, so here's a setup. I just set up the basic definitions in Lean to state what we have. So a magma is just a class of the binary operation, which we can use diamond. Equation 1689 is the statement that for all x, y, and z, we have this particular equation occurring. And equation 2 is the fact that x is always equal to y. And we would like to prove that equation 1689 implies equation 2. So I've broken up Bruno's proof into atomic bite-sized pieces, each one of which just, so we're just going to formalize line by line blindly without really seeing the big picture to see how that goes. So for example, the first step is to introduce a new object S. S is a function not of x, y, and z, but x and z. Yeah, I want it to be that, except that it doesn't like, if I give it a type, then it's happy. All right. So that's S. Then I want to give it F. Sure, but actually let's do it the other way. Let's actually give it the first law here, and then let's just make sure that F is also equal to this other expression. And that's just our real fine. Okay, so the main equation has this form, so let's just make that. Yeah, okay, but it shouldn't be this. Okay. Now there's a pitfall which I did before. I always need to actually have my hypothesis in here and equation for the magma M. Okay, it's not RFL. This one I think can be done by exact. Yeah. Okay, so this is just H. All right. So then there's a claim. This in Bruno's proof, this claim was part of lemma 1, but it was also used later. So I extracted it out here as a claim. Okay, so again, we need to assume equation 9. Okay, so if I have an A and a B and Y, okay, but I need also Y to be an MA. So I also need to exist a z such that y is equal to z times a, then x times y times x, which is SBA, is equal to a. Yes, okay, so this is what I want. Okay, so compiling properly. Something is complaining. Yeah, okay, I need a comma here. All right. All right, so first of all, if that work? No? Okay. Try canonical, the next more powerful tool. Did that work? Doesn't look like it's closing. All right. But yeah, so one thing that was that canonical struggle with is that there's an existential here. But if I open it up like that, from syntax, then canonical can work it out. Okay, so canonical needed just a little bit of an assist there. Okay, so I have this claim. Fine. Okay, next step is to do this lemma. Okay, so lemma one. Okay, for all A, B, and C. Thank you. I need my hypothesis and we put that up front. I need that SBA. Yep. Okay. No, I don't need all the extra text. I already have it. Okay. So I have this claim. Okay. So first of all, I will set x equal to xDA. Okay. Then like the claim is that okay, I have claim for all y if y is in M and y is in yeah. Thank you. Yep, that's actually what I wanted, except that I'm using x now, so I'm going to change that. So this should actually just be the claim that I already proved. Yep, there it is. Okay, so then apply the main equation to these values of xy to conclude for any z. Yeah, so these are notes. So in my first attempt, I got stuck because I didn't understand what y and z were. They're arbitrary. So the claim that I need here, so I'll just make it, no, stop that. Okay, so claim that for all z, I want SDA to, yep, okay. That's not as simple as that. So, okay, first of all, okay, that doesn't work. It's going to work. Okay, did not do that. So I'm going to apply the claim to a specific y. So I'll set y to be, for example, a times a. I need my hy. All right, I don't need exact alpha because use it already works. Okay, now can I canonical my way out of this? It's taking much time, did not solve the problem. All right, so I have to think about, I have to apply the main equation. Okay, so the main equation is up here. Just make a copy of it just to stare at it. Here's the main equation. The main equation is x is equal to y times x and SCX. I want to prove A is SC. Okay, I think I want this to be x. So let's first of all, change like that. Okay, well, first of all, does that help? Did that help you at all? No? No, that's not what I want. It's supposed to equal main equation. Okay, why don't I just convert it? Oh, it doesn't know what it's. It wants A to be something times x. All right, let's see. Why is A something times X? Okay, X is SBA, and I know that so I have to do a calculation. I need to show A is something times X. X is SBA. I have my main equation. A is equal to SBA. Oh, that looks promising. Maybe I'll I need there to exist a W such that A is equal to W. So I've kept that. Yeah, I mean, yeah, then I can set W, right? Oops. Main equation, I want X is A. Another thing, I can't just convert in my head. X, Z, Z. No, I want A to be y times X, so Y should be just W. Well, I have to obtain the W, don't I? Okay. Let's not do the article there. Okay, so I'm done once I conclude this. Okay, now can this be done by Canonical? Yes, okay. All right. Yeah, so Canonical didn't solve it completely, but I had to manually prove it until I could reduce it something it did solve. Okay, so I got the H1. So that is done. Okay, then set Z equals SCB. Sure, let's do that. Okay, then note that, okay, so note that SBAZ equals AB. Okay, yeah. So let's do this. Okay, so first of all, I just, oh, I get it. Okay, don't even think about it. It's done. To simplify the right-hand side and get as announced. So, all right, I got all these steps here, so maybe I'll just calc this. Okay. Okay. Okay, actually, I want SDA to equal. Okay, so calc SBA is equal to A times, that's not quite right, A times diamond, slightly wrong. You want SBA D times Z. Okay, let's do that later. That's supposed to equal A times B times Z. No, that's not right. A times B times Z. Yeah, you can see that GitHub Copilot is trying to help, but in this case, it is not actually giving the right answers, but that's fine. And then that's supposed to equal A times FBC. Okay, I'm supposed to finish the goal. So let's yeah, okay, so which of these can be done easily? Okay. All right, that was easy. That's easy. That's easy. That one's not easy. Okay. Can you look it up? All right, this one I actually have to look at. We want A of FBC to be A times Z. Z is SCB. Yeah, that doesn't look the same. F, just to remind myself, F was x times syx, so FBC. Right, let's just start this bit. If I, what can I get rid of? I congruent this. Oh, it's one of these things, isn't it? This looks like and why is B times C equal to FBC? Right. Oh, okay. Haha. Okay. So GitHub Copilot provided me the wrong claim here. That's why I'm choking at the end. Okay. So that should be an FBC, and then I don't need this last step. Done. Okay. So this is now no red lines. Number one is proven. Okay. So that is actually a pitfall. Is that when you rely on GitHub Copilot to provide the statement of your proof, you actually have to check that it gave what you needed. Okay, number two. For all A, there exists B, C, and D such that FBC equals SDA. Okay. For all A, there exists B, C, D such that FBCD equals SDA. Fine. Okay, that actually is correct. Thank you. Okay, so first by the definition of F, you have FBC equals BSCB. But I don't know what B is yet, or C, so I'll just have that. Oops. I'll have that as a claim. Okay, so for all B and C, I want FBC to equal B times SCB. Okay, this should, is there something obvious? Oh, okay, that's probably just the definition, right? Okay, take B equals SX A for some X. Okay, so any X will do. So I will set X to A and set B to be A, and I'm going to use B. That's my first qualifier. Okay, and then rewriting B equals A as CB. Let's see why that's true. So I have, but C is not given yet. So for all C, I want what I want B to equal A times SCB. Well, what's the reason? Why can I do that? Maybe I actually need to use what B is. Let's unfold these first. Is it clear? Okay, none of my easy things worked. All right, so why is B equals A times SCB? That looks a bit like, but that's got an F in it. Rewriting B equals A times SCB. So I actually have to look at, maybe that's the main equation. That does look like the main equation. Right, let's put the main. What am I? Okay, so I'm trying to move SXA is equal to A times SC XXA. That does look a lot like convert to the main equation. I need to write A as something times SXA. But that's actually what that equation gives me. Okay, so I need something. So what will I convert to? Okay. So All right, let's try with it. Okay, so I need there to exist a W such that, you know, what one again? I wanted A to be something times SXA, all right? So I want something A is equal to W. I have that, and then I steal it. Then I can finish. Okay, so I just need to prove this. All right, let's just do the usual thing. Let's just try. For some reason it's a bit slow. Oh, okay, exactly was able to do this. Okay, so I finished H2. Fine. Okay, don't do this anymore. And using the first equation, group number one, you find that this is equal to this. Okay, so FBC, is C defined for me yet? Not yet, so I actually need to declare it. FBC should equal A times SE. Ah, thank you. So is this okay? All right, can't do it exactly, so we actually have to follow the proof. We have to use the fact that B is, okay, so I need to substitute this. Okay, so let's just substitute the reason we did. Oh, and it's now done, right? I guess it was quite true by definition. Okay, now H4, which has the desired form. So it's supposed to, we're supposed to finish now. Can I, that's that? I don't know. I can open. Okay, oh, all right. So we can actually close the argument. All right, done. Okay, lemma 2 is done. Lemma 3. For all A, there exists an E such that SEA equals A. Yeah, that's actually what I want. Good. All right, let's do that. Proof. No, let's not do that. Okay, proof. Left, multiply the equation A1 by A cubed equals A squared plus 1. That's actually, well, okay, so let's set A squared to be A times A and set A cubed to be A squared by 3. Left multiply to get this identity. Okay, so I'm claiming, so A is given, B is not currently, this is for any B and C. Okay, so for any B and C, I want, that's A2 times A. Okay, so A2 times A times, oops, times SBA is equal to A3 times A times FBC. All right, do the usual things first. Okay, might also work this out. Maybe not. Okay, so we have to left multiply A cubed, so we have to cancel the A cubes. Okay, so let's just do that. All right, now can Canonical work? All right, exact words. Exact piece Canonical. All right. All right, so we've gotten that far. Okay, take BCD as in lemma 2. Lemma 2 was the claim that every A there is BCD such as something. All right, so it's just an obtain. And in fact, it's that obtain. Yes, all right, that's what I wanted. To rewrite A FBC as FAD. Okay, let's do that. Yeah, so you see, I'm just blindly formalizing line by line here. You see, A, B, C, D, they're all given. So I just need, in fact, yeah, I just need that. Yeah, this is something that is easy. All right, it's easy. Okay. On the other hand, level 1 implies that A cubed is equal to FA times FAD. Okay, so let's just prove that. A cubed is equal to A times FAD. That's not the proof. Okay, this is something that, oh, okay, that's just number one as advertised. Fine. So overall, we get A is equal to this thing. Okay. So yeah, that's up to be the right statement with the wrong proof. But I can go look for the proof. Not bad. Like that. Okay. So you think as to why this is true. I want A to equal FAD, FAD. I've got H4 that fits, so presumably that's part of what I want to do. So let's just substitute that in. Now is this easy? So I can just, no. Okay, so why is A3 times FAD? That's not H4 again, it's a little different. That looks more like this. Let me see. Stick in. So why is A cubed times FAD? I did have this previous thing. Wait, I did, this is only part of what I wanted. Go back here, this is just the second half. What I want actually is for any B and C, I guess still. I actually want A to be this thing. So I missed a step. So that can, okay, but now I have that step. Does this step become easy? Yes, it does. Okay. So that was a problem. I had moved a bit too fast, which is as desired. Okay, so let's see. Okay, done. Okay, finally, we actually proved the actual theorem. So this is the actual statement. Yeah, that statement, thank you. For any A and Y using the notation, okay, so we want to get that A is equal to SAY. Okay, so A, okay. So have H1 for any A and Y and M. We want A to equal SAY. Okay, so what we're doing is that we're going to use the E first. So we're going to obtain the E from number 3. So yeah, that's a straight obtain. Yeah, thank you. That's my E. And then this one big calc statement. Okay, so I want A to equal Y times A times SEA by some argument. That's supposed to equal Y times A times A by some other argument. Oh, that actually works. I'll keep it then. And that's supposed to equal SAY. Smart. So that's a working argument that will complete that goal. All right. Sorry, to just close it up. All right. Well, which of these are easy? Is this easy? Yes, this is easy. Is this easy? Not that easy. So this. All right. My info view has stopped responding. What are we trying to do? YAA equals SAY. Should YAA be SAY? That's just definition. That just has definition. So that should actually just be definition. Yes. All right. In setting this back, the main equation gives ZY equals Y. Well, that's pretty, okay. So it's a pretty strong claim, but let's see it. For any A, Y, and Z. Okay, so for any A, Y, and Z, Z times Y, I don't know where that came from. Z times Y should equal Y. Well, Z times Y times A should equal Y. All right, it's just exact substitution. No. What is the actual message in? Oh, hang on. Oh, there's a sorry here, which I taking that away. Okay, can you solve this? Are you doing? All right, my canonical doesn't seem to have solved it. All right. I want z times y times a to, so it's back to the main equation. Okay, so I have to substitute, let's pull up the main equation again. Where is it? This is a similar thing from before, I think. I want y equals z times y times a. Yeah, so let's just reflect it. That should match the main equation. Okay, so if I match it, I need a to the s times something times y. Ah, but I see that, okay, so let's convert 3. I need a to the s times something times y. Okay, this is take that for granted for now. Okay, if we select it, if I do that, yeah, okay, so that's why I needed to close the argument. I needed this w. Okay, this is existential. It's not going to work, but I think canonical will. Yeah, all right. So that gives me H2. All right, go to this. Thus, AB equals D equals C for any ABCD. Okay, so for any ABCD, A times B is equal to C. All right, well, first of all, let's see, can I just, yep, I can one-shot this. Nice. Thus, A equal BCD for any ABCD. Okay, so I want A equal D. Yeah, I'm getting very close to the goal now. Okay, so again, yep, I don't need to think about it. That's done. And now I should be done, actually. Yep. All right, so that's the proof. 33 minutes. Okay, so last time it took 48 minutes. But it got formalized. So you saw how the tools helped. Well, they both helped and hindered in that like every step became easier to accomplish. But I lost a sense of what was going on. Really was just formalizing line by line, not really understanding how things connected, and just kind of hoping that the tools would justify each step, which half the time they did, and then the other half you actually had to read the human text, the human proof, and then try more old-fashioned tactics to simplify. But you can try one step and then apply the automated tool again, and it basically worked. So that's how you formalize with computer assistance. It's a different way of formalizing. So you strip out all the conceptual strategizing and you just solve all these mini problems of just completing the next line. But it can work. So for things that are kind of medial and not very conceptual. So I mean, this is, yeah, this proof, I don't think there's a high concept explanation. I mean, you could make it a bit, maybe you can clean up a little bit and maybe try to introduce some group theory terminology or some actual mathematics. But you know, it is a tedious proof, and maybe this is the type of thing that automation is supposed to be good at. Okay, so I'm going to stop here.